Welcome everyone. This presentation will cover manufacturing process of cotton, properties of cotton, uses and care of cotton. Let us see the manufacturing process of cotton. The first step of cotton manufacturing involves carding, followed by doubling, combing, drawing, roving, spinning and weaving. These are the series of manufacturing of cotton yarns. Manufacturing cotton yarn. Carding. Before the raw stock can be made into yarn, the remaining impurities must be removed. The straightening process puts the fibers into a somewhat parallel lengthwise alignment. This is necessary for all staple fibers, otherwise it would be impossible to produce fine yarns from the original tangle mass. The initial process of arranging the fibers in a parallel fashion is known as carding. The work is done on a carding machine. The lap is passed through a beater section and drawn on a rapidly revolving cylinder covered with very fine hooks or wire brushes. As the cylinder rotates, the cotton is pulled by the cylinder through the small gap under the brushes. The teasing action removes the remaining trash, disentangles the fibers, and arranges them in a relatively parallel manner in the form of a thin web. The web is drawn through a funnel shaped device that molds it into a round rope like mass called card sleeve, about the thickness of broomstick. Card sleeve produces carded yarns or carded cotton, serviceability for inexpensive cotton fabrics. Doubling. After carding, several sleeves are combined. This results in a relatively narrow lap of compactly placed staple fibers. The compactness of these fibers permits this cotton stock to be drawn out to a sleeve of a small diameter without falling apart. Combing. The sleeves then continue to a combing machine where the fiber is put through additional straightening called combing. Here the fiber shorten than half inch and impurities are removed from the cotton. Drawing. Drawing is the action of pulling the staple lengthwise over each other, thereby producing longer and thinner sleeves. Roving is the final product of the several drawing out operations. Roving has no tensile strength, it will break apart easily with any slight pull. The sleeve is drawn out to a thinner strand and given a slight twist to improve strength, and then wound on bobbins, a spool wound with a thread-like product for storage. In this stage, the cotton stock is about the diameter of a pencil lead. Having completed this process, it is now called roving. The roving bobbins are now ready for the spinning process. Spinning is the last process in yarn manufacturing. The roving on bobbins is placed in the spinning frame where it passes through several sets of rollers running at successively higher rate of speed and is finally drawn out to yarn of the size desired. Weaving is the process of method of fabric construction. The weaving process uses yarn that, depending on how it lies into the woven goods, now assumes different names. These yarns may now be either a warp or a weft yarn. Warp refers to the yarns that run lengthwise in woven goods. In the preparation of warp yarns for weaving, hundreds of yarn strands are wound from cheese cones onto a large warp beam. Yarn of these are then coated with a sizing compound called starch to added strength for weaving. The sized yarns are then wound on a loom beam that will be placed on the loom, a machine used to interlace yarns to form cloth. Weft is the yarn that runs crosswise in woven goods and may be referred to as filling yarn. Physical properties of cotton. Fiber length ranges from 10 to 65 mm depending on the variety. Longer fibers are generally stronger and more desirable. Fiber diameter measures 11 to 22 microns. Fine fibers produce softer, more comfortable fabrics. Color typical white to yellowish but naturally colored cotton brown green exist. Luster. Low moderate with mercerized cotton exhibit higher luster. Mercerization is a treatment that increases luster and strength. Mechanical properties like strength, high tenacity when dry and stronger when wet. This indicates that cotton fiber have good resistance to breaking. Elongation 6 to 10% at break. This means the cotton fiber can stretch slightly before breaking. Elasticity low, resulting in poor wrinkle recovery. Cotton fiber do not easily return to their original shape after stretching. Resilience low, wrinkle easily. Cotton fibers tend to retain wrinkles and crease. Thermal properties like flammability burns readily, chars and continue to burn after removing from flame. Heat resistant can withstand ironing temperature up to 204 degrees Celsius. Other properties like moisture absorbency, high absorbing 24 to 27% of its weight in water. This makes cotton highly hydrophilic, water loving that means. Density 1.54 grams per centimeters. Overall, cotton is a natural, breathable, and absorbent fiber with good strength and durability. However, it can be prone to the wrinkling and may require ironing to maintain its shape. Cotton is primarily composed of cellulose, a natural polymer that provides strength, durability, and rigidity to the fiber. The cellulose content in cotton is around 94%, with minor amount of the other substances include protein, pectins, waxes, ash. Reactivity with acid. Strong acid, concentrated or diluted strong acid such as hydrochloric acid or sulfuric acid can damage cotton fibers, causing them to weaken or break. Weak acids such as acetic acid or citric acid have little effect on cotton fibers. Reactive with alkalis. Mercerization is a process that involves treating cotton fiber with sodium hydrogen to improve their strength, luster, and dye affinity. Reactivity with bleach. Hydrogen peroxide is a common bleaching agent used to cotton as it is relatively gentle and effective. Sodium hypochlorite. This is another common bleach agent used for cotton, but it can be more aggressive than hydrogen peroxide. Chlorine bleach. While chlorine bleach can be used to bleach a cotton, it can degrade the fiber over time, leading to loss of strength and elasticity. Dye affinity. Direct dyes, reactive dyes, wet dyes are applied to the cotton fiber using a reducing agent, producing deep and rich colors. Biodegradability. Cotton can be broken down by microorganisms such as bacteria and fungi into carbon dioxide, water, and biomass. The biodegradation process can be influenced by factors such as temperature, humidity, and oxygen levels. Resistant to microbes, cotton can provide a rich nutrient environment for the microorganisms to grow, especially in humid or wet conditions. To prevent microbial growth, cotton should be kept dry and well ventilated. Resistant to sunlight, ultraviolet light can cause common damage to the fiber to weaken the fiber and causes yellow or become brittle. UV light can also cause cotton dyes to fade or change color. Chemical resistance. Cotton fiber can withstand exposure to many organic solvents such as ethanol, acetone, or hexane. However, some solvents such as chloroform or carbon tetrachloride can damage or dissolve cotton fibers. Environmental impact. Pesticide use. Cotton production often involves the use of pesticides which can harm beneficial insects, contaminate soil and water, and affect human health. Water use. Cotton production requires significant amount of water, especially for irrigation. Organic and suitable cotton. Many cotton producers are adopting organic and sustainable practices to reduce environmental impact of cotton production. Care of cotton fabric. Avoid direct sunlight while drying. Wash in temperature no higher than 40 degrees centigrade. Use mild detergents. Do not use bleach. Avoid long-term storage to prevent creases. Uses of cotton. Cotton is used for apparel like shirts, t-shirts, jeans, dresses, underwears, and socks. It is also used in home textiles for bed sheets, pillowcases, blankets, towels, and curtains. Cotton is also used in accessories like hats, scarves, and bag making. Industrial uses of cotton. Medical supplies. Cotton is used in medical applications such as bandages, gauze, and cotton swabs. Cotton is also used in air and liquid filtration systems, and it is used for the tarpaulins and canvas. Heavy duty cotton fabrics are used for tarps, canvas, tents, and sailcloth. Upholstery cotton is used in furniture upholstery for its durability and comfort. For home furnishes and furnishings, cotton is best suitable because of its good absorbency and dirt and soil repellency. Cleaning productions, cotton is used in mops, dusters, and other cleaning tools. Personal care products. Cotton balls and pads are used for making removal, applying lotions, and other personal care routines. It is also used in diapers and wipes. Then, cotton is also used in agriculture uses. The seed oil of cotton is extracted from the seeds, is used for the cooking and as an ingredient in various food products. It is also used in animal feeds. Cotton seed meal is used as a feed for livestock. Other specialized applications of cotton are art supplies like cotton canvas is a popular choice for painting. Bookbinding, cotton fabric is sometimes used for the covers of books. Currency, it is also used in some countries like the use of cotton fiber to produce banknotes due to its durability and resistance to wear and tear. So, to conclude, cotton is a versatile and widely used fabric. It is the most widely production and consumed natural fiber globally, prized for its comfort, durability, and versatility. Thank you.